Friends, let us start with one more problem on voltage to voltage converter. So the problem is like this: design voltage to voltage converter for input voltage within range 3 volt to 1 volt and output voltage within range 0 to 5 volt. So we will list out the given things in this particular problem. So let us say given things. So what is the input we have? What is the output we have? Input is voltage, output is voltage. Okay, so input voltage, let us say VA first volt, that is 3 volt. Corresponding output voltage is 0 volt. Let us say input voltage VB is 1 volt. Corresponding output voltage VOB is 5 volt. We observed that input voltage is decreasing, let us say 3 volt to 1 volt. Corresponding output voltage is increasing from 0 to 5 volt. So try to understand this problem. So how the characteristic curve for this particular type of problem will be, let us say this side we have V in, this side we have V out. Okay, so if input voltage is 3 volt, corresponding output voltage is 0 volt. So let us say this is 3 volt, corresponding output is 0 volt. If input voltage is 1 volt, let us say this is our 1 volt, corresponding output voltage is 5 volt. Okay, let us say this is 5 volt. So we have to develop the system for this. This is VOA, this side our VA, corresponding this is VOA, this is our VB, this is corresponding VOB. So we have to design the circuit for this. Now see, it is being observed that in this type of example, that is, as input is decreasing and output is increasing, slope of this line is negative. So we should have circuit which where the slope of the system should be negative. So what should be the circuit for that? So as compared to this particular, so we should have op amp based circuit where the slope could be negative. Here we are applying V, this is R com, this side positive, this side negative. Let us say this is our R1, this is RF, this is ROS. Here we are applying VOS, this is plus V, this side minus V. So like this circuit we have to go for, and here we are getting VO. Okay, so if we are getting the characteristic equation for this particular, we will get the equation like VO is equal to minus RF by R1 into V minus RF by ROS into VOS. At RF is equal to ROS, the equation becomes VO is equal to minus RF by R1 V in minus VOS. So let us say this is equation 1, or if we are observing RF by R1 is equal to the gain of this particular amplifier. Okay, and this particular gain, if we are putting unity, the equation will be becoming like this. So this particular factor gives us the negative gain, and for this particular type of line the slope is negative, so we can develop with this type of circuit. So the equation is in the form VO is equal to minus M into V in minus VOS. Okay, so start with putting these values in this equation. Let us start with first one. Let us say VOA is equal to minus M into VA minus VOS. Okay, so put the values. VOA is equal to 0 is equal to minus 3 M minus VOS. This is, let us say, equation 1. Similarly, VOB is equal to VB minus M VB minus VOS. So put these values. VOB is 5 minus M minus VOS is equal to, this is equation 2. Sorry, this is equation 2, this is equation 3. Subtracting equation 2 from 3, what will get? 5 is equal to this minus and this minus becomes plus, so minus minus become plus, so that will be 2M. So M is equal to, we are getting 5 by 2, that is 2.5. This particular we got. Okay, because this 3 becomes positive, this is negative. Alright, now putting this value in any one of this equation, what we'll get? Let us say we'll put in this equation 2. Equation 2 will get 0 is equal to minus 3 into 2.5 minus VOS. So 2.5 into 3, that is going to be 7.5, and this is minus this factor. If it is coming on this side, it will become plus. So we'll get VOS is equal to minus 7.5. Let's say this unit is. So by adjusting VOS is equal to minus 7.5 volt and M is equal to 2.5, we can get corresponding input and output. But this equation is that is, we have considered like that M is equal to RF by R1. Okay, and RF is equal to ROS, that we have assumed. Okay, so putting R1 is equal to 10k in above equation, we will get that M is equal to 2.5 is equal to RF divided by 10k. So we will get RF is equal to 2.5 multiplied by 10k, that is 25k. This is one we got. Similarly, ROS is equal to RF is equal to 25k. This is also we got. So, and selecting RCOM is equal to 10k, we can develop the circuit. Now see, we have all parameters. We have VOS, that is minus 7.5 volt, ROS, that is 25k, RF 25k, R1 10k, and this RCOM also 10k. By adjusting these values in the circuit, we will get this particular equation, and this circuit will give us the output, corresponding output for this corresponding input. So this is V to V converter. Only we have to keep in mind the slope of the line is negative, and for negative slope we should select this circuit and this as a characteristic equation. For this, the constraint is that Rf is equal to ROS. Okay, and Rf by R1, this gives the gain of this particular circuit.